hazard analysis and critical control point. To establish this hazard analysis and critical control point, what do we need to do in the steps? What are the principles and what are the steps to be followed in food processing plant? That we will be discussing in detail. Hazard analysis and critical control point implementation in food processing industries. So the name implies hazard, that is a danger or harmful effect which may create. Then we need to analyze, that is we need to investigate about the hazards. Then we need to find out the critical hazards out of the overall process. Then we need to find out the control factor which limits the hazards presence in the product with the reference to processing. How we are doing that, let us discuss in detail. Before going about the detailed discussion on principles and steps in HACCP implementation, we need to have a small brief on what is HACCP, why do we need to do, why do we need to implement HACCP in food processing premises. HACCP is considered to be preventive approach rather than reactive approach. That is, if when we establish the HACCP system as per the food safety standards, we could able to control or prevent hazards, whereby we can provide a safe food to the consumers. The main objective of this particular system implementation is prevention using a structured method for hazard identification and control. So we need to prevent the food safety issues or hazards by adopting a structured method to control. We need to implement this HACCP system does not mean that only in the processing premises, which starts from receiving of the raw material. We need to follow a systematic approach, that is, as mentioned before, a proactive approach starting from receiving of the raw material till it reaches to storage and dispatch, whereby we can have a complete documentation, whereby we can ensure if there is any issues or any complaints or any food safety related complaints or grievances arises from the customer or from the regulatory body, we could able to identify and we can address the issues quickly. It is very much advantageous over the previous method of quality control method. It is considered to be one of the HACCP system as quality assurance system, whereby we are ensuring or assuring the product is safe to the consumer, whereas the previous approaches were quality control approach, where we will check the final product quality with reference to the standards. If there is any deviation, either we need to rework or reprocess or discard the material. So when compared to the previous quality assurance related issues, this is considered to be one of the best method or approach to ensure the safety of product. So when it comes to hazard analysis critical control point, we need to know what is the hazard, what all the hazards can enter into the food stream, from where these hazards can enter into the food stream, and how we can control these hazards, whereby we can ensure food safety. The history of HACCP goes back to 1960, where NASA requested a zero risk product for astronauts. This HACCP system was first implemented by Pillsbury, that is General Mills, to provide zero risk food products for astronauts at space. this HACCP system consists of 12 steps. Out of these 12 steps, 5 steps are considered to be preliminary steps, and the remaining 7 steps are principles. The preliminary steps, let us discuss about each and every steps in detail. The first step is make a food safety team. This food safety team is a multidisciplinary team with respect to the domain what they are working, that is the department what they are working, also with respect to their knowledge level on particular department. This multidisciplinary team includes people from food safety and quality assurance, then people from production, sales, product development, that is R&D, then supervisors, sanitation or hygiene people, management people, HR people, maintenance engineers. All these people will work under the headship of leader, team leader. Generally the team will be led by food safety or quality assurance head in that particular organizations. This team consists of multidisciplinary people, as we mentioned here. Then we will be working on various aspects. The second step in HACCP implementation is description of the product. We need to describe the product for which we are going to implement HACCP system. This description will include the list of ingredients to be used, the raw materials which are being used, the packaging material to be used, as well as the end product. What is the end product? This description should be documented. What is the packaging material, also the raw material specification, ingredient specification, packaging material specification and product specification to be documented. What is the end product, whether the product is coming under ready to cook, ready to eat, or ready to drink, or ready to serve, or some other preparatory products. All the details should be there in the document. We need to maintain the document, including the storage conditions, transportation requirements, what is the grammage, USP, product description, which includes all the aspects. What is the size, packaging material size, everything should be there. The second thing is what is the intended use of the product, that is who can use the product, how should use the product, allergen requirement declaration, whether this product could be consumed for all, or is there any restrictions with respect to the consumers. For example, in case of some of the products which contains high preservatives are generally not recommended for infants, as well as the people those who are having allergens to certain food allergens as listed here. Some may be allergic to gluten, so we need to declare if there is any allergens. All this intended use and instruction to the customers to be displayed in the label. So they need to declare the details in the label as per the regulatory requirements, in such a way that the customer could easily understand and know what they are consuming as an end product. Next one is development of process flow diagram. This process flow diagram with respect to the product. Say for example, in the same manufacturing facility, they may produce different products, but the process flow diagram may not be same. For example, in the dairy industry, dairy manufacturing sector or organization, they will be manufacturing pasteurized milk. They will also be manufacturing paneer. They also be manufacturing condensed milk. The process flow chart for pasteurized milk and the condensed milk as well as paneer will be different. So we need to draw the process flow chart as per the procedure to ensure that the proper plant layout, that is design of plant and proper plant layout being implemented in the process, whereby the product goes in a sequential manner till the end product point. So the fourth step will be flow diagram, development of flow diagram. Then the fifth step will be verification of process flow diagram on site. After developing a process flow diagram, the HACCP team should go and do the on-site verification whether the real manufacturing process is happening as per the process flow diagram already been developed. After verification and followed by a discussion, if there is any variations or if there is any addition or deletion of any process flow processing step which needs to be done, and again they need to ensure the process flow is exactly what is happening in the manufacturing unit. As I told, if they are using different process production line for different products, they have to establish different flow diagram for different production line. Then comes the sixth step. From sixth step, it is considered as principles. Sixth step is the first principle of HACCP, that is hazard analysis. In order to do hazard analysis, we need to list the hazards, we need to evaluate its significance, also we need to identify what is the control measure. Before going in detail, we need to know what are all different types of hazards. Food safety hazards are there. One is biological hazard, chemical hazard, as well as physical hazards in food. These hazards may be either present in the food as such, or it may enter during the supply chain management process in the food stream. So we need to know what all the hazards are there and how we are going to eliminate or reduce the hazards. Let us go in detail about different food hazards. First one is biological hazards. There are two categories of biological hazards. One is visible biological hazards and the other one is invisible biological hazards. The picture representation gives very clear thing about visible biological hazards in food. It could be fly, worms, cockroach, caterpillars, weevils, and other reptiles. Then excrete of those reptiles too. There is invisible biological hazards in food are bacteria, yeast, protozoa, molds, or virus. When it comes to chemical hazards, the sources will be veterinary medicines, fertilizer, packaging chemical compounds, hazardous gases or aerosols, also cleaning and disinfection agents. We will be using, if it is an animal product like chicken or even marine products, prawn and all, they will be using veterinary medicines. Those medicines may be there as a residue in the animal. Also fertilizer which we are using for agriculture purpose. Packaging chemicals which we are using in the packaging material could also be the source. Also pollution from gases, environmental gases and other polluting substances could also be considered as chemical hazards. Then in the processing plant we will be doing cleaning and disinfection using detergents and other cleaning agents. The residue may be there in the processing equipments and which may get into the product in the processing steps, different processing steps. Then physical hazards could be physical ingredients like glass, metal, pieces, air, nails, stones, dust or dirt, which may be coming from the people, those who are in contact with the food, that is food handlers, or it could be from the raw materials, or could be from the machineries, or it could be from the farm source, or it could be from, as we know, from the human, those who are working in the food handling places. So the list is given clearly. Then the next source, as we now discussed, the sources could be either from man, material, machine, or method, even from the environment. Now we will be going to the important aspect, that is risk assessment. Risk is the function of probability of the adverse effect and the severity of that particular effect. Risk will be a function of probability and the severity. Here one example is given, how to do this risk assessment with respect to different steps. We need to list what are possible hazards pertaining to biological, physical and the chemical hazards, and also we need to see whether the likelihood of occurrence of that particular hazard as well as severity of the hazard. Then the product of this likelihood of occurrence of the hazard as well as severity which it creates will give you the risk. We need to do this for each and every processing steps as based on process flow chart. So the risk assessment model will be 5x5 matrix. Here the 5 metrics will be likelihood, that is probability, from 1 to 5, whereas the consequences, that is the impact which it creates, also 1 to 5. Depending upon the hazard which we have identified pertaining to the steps, we need to give the score, and we need to find out whether the risk is low, medium or high with respect to the threat level, that is the impact what it is creating. It has been given very clearly, the color code. If it is low, generally given as green color. If it is medium, brown color. If it is high, orange, and if it is critical, red color. So the score also up to 4, it generally could be considered as low risk. Up to score 6 is considered to be again low risk. Up to the score of 16 could be medium. More than 16, that is 20, 25 are considered to be critical risk. So what are the control measures we need to take? What is control measure? First of all, we need to understand if there is any risk is identified, we need to find the control measure, that is how to control the risk. This could be in either 3 ways. Either we can prevent the risk, or we can eliminate the risk, or we can reduce the risk. The action what we are going to take to control the risk should be either eliminate, prevent or reduce the risk. In general, if you could follow the good manufacturing practices in the manufacturing premises, we could able to achieve lesser risk, starting from following personal hygiene practices, pest control measures, chemical control measures, then training to the people, food handlers about how to handle and how to work in the processing area by having proper specification and documentation for raw material, finished goods, ingredients, packaging material, then proper allergen control, designated place for cleaning and the detergents and other disinfectants. Also maintaining production equipment, proper maintenance documents, then supplier control, having good supplier control with sharing the raw material specification and getting the certificate of analysis from the supplier to ensure the product, the raw material or ingredients or packaging material falls as per our requirement, to ensure the regulatory compliances are met. Then this is an example for hazard analysis for receiving of material in shrimp or lobster manufacturing plant. There are list of biological, chemical and physical hazards. We can find out what is the severity, what is the likelihood of occurrence. The product of severity, that is the number, and the likelihood of occurrence will be 4 by 2 will give you 8. Then we can justify the decision, how it is 8, why it is 8, and what control measures could be taken to prevent the hazard or reduce the hazard into the significant level. This is an example for hazard analysis. This is example for a single processing step. In a similar way, we need to do it for all the processing steps. Then we can find out the critical control point. For each and every step, we need to raise set of questions. This is called as CCP decision tree. In HACCP implementation alone, if you are going to implement only HACCP system in place, we can adopt this method to find CCP. If we are going to implement FSSC or ISO 22000, the CCP will be fixed based on other method. In the critical control determination, there will be set of questions. Depending upon the answer for the set of questions, we can find out whether the particular step is considered to be critical control point or not a critical control point. The first question will be, do control measure exist at this step or subsequent steps for the identified hazard? If your answer is yes, then we have to raise the next question, that is, does the step eliminate or reduce the likely occurrence of the hazard to an acceptable level? If your question answer is yes, then it is considered to be a critical control point. If your question for the first question, if your answer for the first question, do control measure exist in the step or subsequent steps for the identified hazard? If it is no, is control at the stop necessary for safety? If yes, again we need to modify the step and we need to go for the first question. If your answer is no for this question also, then it is not considered to be critical control point. If your answer for the second question is no, then we need to raise the third question, like, could contamination with identified hazards occur in excess of acceptable level, or could this increase on to unacceptable level? If your answer is yes, then we need to raise fourth question. Will a subsequent step eliminate the identified hazards and reduce the likely occurrence to an acceptable level? If it is no, then that particular step is critical control point. If answer for your fourth question is yes, then it is considered to be not a critical control point. If answer to your third question is no, then also it is not a critical control point. This is the very basic or art of this HACCP system, that is critical control point, to determine the critical control point. We need to raise the question and we need to get the answer. Based on the answer, we need to fix whether this is CCP or not. Then step number 8, that is next principle, is establishment of critical limit. When we are establishing a critical, after identifying critical control point, establishing critical limit is also another one important factor which will determine whether this particular step could be a critical control point or not. If we are unable to fix the critical limit for the particular step, then we cannot consider that as a critical control point. What is critical limit? The critical limit should be like measurable quantity. If you are giving a particular treatment in the process, for example, in case of vegetables, blanching is considered to be one of the treatment to inactivate enzymes, also to reduce the microbial load with respect to vegetables. Either vegetables to be frozen or dehydrated, dried or canned or minimally processed. Blanching is considered to be one of the heat treatment for the vegetables to inactivate enzymes, whereby we can minimize subsequent changes in the product. Also, we can minimize the microbial load and extend the shelf life. So, if the blanching is considered to be a critical control point, what could be the critical limit? The blanching time as well as blanching temperature could be critical limit. By fixing the critical limit within the range, we need to understand whether we could able to inactivate the said enzymes, that is peroxidase, for example. Peroxidase, we need to test whether peroxidase been completely inactivated or not within the set temperature and time duration. Then it is considered to be critical control point. There could be another critical control point. For example, in case of grain processing, iron pieces could be considered as critical control point, since metal pieces or iron pieces which get into the food stream is considered as one of the physical hazard. That physical hazard needs to be eliminated or reduced, right, or prevented. It should be generally zero, it should be, okay, physical hazard. So how to do? We can have a metal magnetic separator. This magnetic separator at a different locations, we can fix it in the process flow of the material. So we can periodically take out the magnetic separator and we can collect how much iron and iron particle being collected in the periodical time interval. So that could be considered as one of the critical control limit. Okay, if it is more than certain level, we can ensure that it is beyond the critical control point. We have to take appropriate action. Let us discuss that in detail. How to establish the monitoring method? As I told, we need to plan a sequential observation. If it is blanching at every 30 minutes or 1 hour time interval or 15 minutes time interval, we need to test peroxidase value, whereby we can ensure the blanching is completed. Say for example, if magnetic separator, if magnetic separator is considered to be CCP, we need to remove the magnetic separator at alternate days or every day as per the documented procedure with the previous experience, and we need to quantify how much iron pieces are there. So and we need to document that. That is called as establishment of monitoring method. How often we are doing, what is the maximum limit and what is the minimum limit, we need to document. Then as we have fixed maximum and minimum limit, if there is any deviation, what corrective action do we need to